Thank you, Pekka, and good evening. I hope you can hear me okay. I've got a bit of a head cold, so if I sound as though I've got cotton wool somewhere in my head, it's probably because I have. I would like to share some of the work that we're doing currently and have been doing now for, I guess, 6, 7, 8 years now at Aalto, looking at the issue of not just circular economy. When we started thinking about it, we didn't really think of it in terms of circular economy. It was more about resource efficiency. I think the term circular economy hadn't really been coined at that point to any great extent, and it's only in the last, I guess, 5 years or so that really it's taken off as a concept. A little bit like sustainable growth. I think circular economy is a little bit of a slightly oxymoronic in the sense that I don't believe you can have sustainable growth, and I don't believe you can have a truly sustainable economy either. I mean, there's always going to be losses in the system, but that's another point, and maybe come on to that a little bit later on in the presentation. I have to confess to being very nervous because I've never spoken in front of a crowd of so many architects. So I'm a mechanical engineer by background. I've found my way into wood about 25 years ago. So a lot of the concepts when it comes to the use of wood in buildings, I would have to say I'm not really that familiar with. So you can please shout me down. Maybe not shout, but maybe just point out where I go wrong, by all means. I'd like to talk a little bit about some of the programs that we are dealing with. Okay. So, I mean, no surprises here. I think everybody is fully aware of the impact of buildings and construction. Approximately half of all materials that are extracted go into construction, into materials. And was it only last week I was looking or seeing some figures presented where the expectations for the extraction of materials are set to increase still phenomenally. So it makes you wonder, given what's been happening over the past 6 months or so in terms of climate change and so on and so forth, how we can continue this trend. It's clearly not possible. Around a third of all emissions, CO2 emissions, are related to the production of energy and materials in relation to buildings, and around 40% of energy consumption. So whichever way we look at it, I mean, there's a fairly huge impact. But also, what makes me kind of a little bit motivated about this is that there's also a huge potential to make an impact. So if we do something, if we make some changes, we can actually have some fairly significant changes to the overall situation in terms of resource consumption and emissions. So that's something that I think we have to take as a positive. Maybe you can tell from the accent, I'm not from Finland, I'm from the UK. We don't have a great tradition for wood construction there. Finland does have a great tradition for using wood, maybe not in all sectors, and we could actually do a lot to improve that. Maybe I'll come on and touch about that a bit later. But why the interest in wood? And I think from the sustainability perspective, then one of the key aspects is that when we're using wood as a structural material, we're replacing another material, usually concrete or steel. And the advantages to that is that when we're using wood, well, you can saw wood by hand. When you come to work with metals, you can saw it by hand, but it's an awful lot more work. There's a lot of energy required in order to manufacture and to process steels and concrete. So there's a lot more embodied energy. So that has a lot of carbon implications, carbon emission implications. So when we use wood, we can substitute for these other materials, and that has a very positive effect. The other thing is that wood is made from carbon dioxide, water, some sunlight, and some other compounds. And approximately half of the mass of a piece of wood is carbon. And of that, if we think about when we're creating a piece of wood, we require about 1.75 kilograms of carbon dioxide is required in order to make 1 kilogram of wood. So for every kilo of wood, we're saving, if you like, storing away approximately 1.75 kilograms of carbon dioxide. So we can think about wood in long-term applications as a long-term carbon store. For sure, when the wood is destroyed, it's burned or it biodegrades, then that carbon is then re-emitted back to the atmosphere. But if it's in place in a building or an artifact for 10 years, 20 years, 30 years, a century, 2 centuries, 1,000 years, then that carbon dioxide has been retained, has been kept away from going back into the atmosphere for that length of time. So there's a positive carbon storage benefit and story to be told from utilizing wood. And an aspect, I'm going to talk about these first 2 points tonight. I'm not going to talk about the other aspects, which Becca has heard me talk about many, many times, probably is very sick and tired of hearing about it. But also then there are energy benefits because wood has very interesting material characteristics, it's a good thermal insulator, it's visually very appealing, I mean it has good tactile properties, and all these kind of features make wood a rather nice material to live with. And also we can utilize it to even to passively control the interior environments of buildings and of rooms, living spaces, and that can lead to some good health benefits and certainly benefits in terms of levels of comfort and well-being. And I think that's something that, well, certainly at Aalto, I've been talking quite a lot to many of our architect colleagues, and I think that's a very positive story to tell. Okay. But I think I think that nobody really disagrees with the fact that there's a great potential to increase the climate change or the sustainability, if you like, of construction by utilising more wood. So on the right, the left-hand side, I should say, we certainly need some kinds of mechanisms or incentives in order to promote the use of wood in construction. It's not happening at a rate. I mean, in certain areas, residential buildings, for example, yes, it's well established, but in other areas, multi-storey buildings, for example, there's a lot that could still be done in order to promote and to roll out the utilisation of wood. Well, we are faced with some possible problems in the long run, namely the supply shortages. We know that we have a big forest resource here in Finland with something like about 100 million cubic meters of wood growing annually, of which we cut and utilize something like 60 million cubic meters annually. You would think that there's a potential to increase the amount of wood going into wood products of all sorts, not just wood construction, but also of paper products and chemicals and fibers and things like that. But there comes a point where we can't take more out of the forest without seriously having to think about the loss in biodiversity and the other ecosystem services. And if we think about climate change and maximising the climate change potential of utilising wood, we need to think about the resource. And I think all too often we don't think enough about the resource base. Where does wood actually come from, and what are the implications of utilising wood? So we need to have this in mind, and there's been studies done to say that, well, yeah, okay, within the next 10 or 20 years, we're going to run into some problems when it comes to the sustainable supply of wood fibre. So the question really arises then, what can we do? How could we, on the one hand, how can we maximise the storage of carbon in wooden buildings? How can we maximise the benefits of substituting other materials without then compromising the ability of forests to sequester carbon from the atmosphere, act as a sink, and also to retain the biodiversity and other ecosystem services? So that's a big question, I think, that we have to kind of grapple with. And this really, I think, requires a slightly different approach to our thinking. We need to think at a very much a systems level. We can't think of things in isolation. We can't just think about only the wood value chain. We can't think about only the construction. We can't think only about forestry. We need to include all the various actors and stakeholders in this system to create a compromise and an optimized system that maximizes the potential of wood, both in the forest and in the built environment, to store and mitigate climate change, store carbon and mitigate climate change. So we need to think about it in this kind of systemic way. And this is something we're now starting to approach the problem from this systemic perspective, rather than looking at kind of single issues. So I was talking moments ago about resource efficiency. That's where, or materials efficiency, which is where we really started this discussion about. And of course, we can think about efficiency in different ways. When we think about the application to the wood value chain, we could think about the efficient utilization of the raw material. This is something that the forest industries are very good at. So a unit of biomass, a log, can be broken down into sawn timber, it can be broken down into chips that can be used as a feedstock for making various polymers or fibers, paper products, and a whole range of different things. What's left over can be used in other material applications or to produce energy. So it's an efficient way of utilizing materials already. There's a couple of examples here. Aalto has done a lot of work looking at producing, for example, alternative fibers to cotton and other fossil-based fibers for textiles. These are based on forest resources. So there are many ways in which we can increase the efficient utilization of biomass. The way we can look at efficiency is also through the longevity of products. So everybody says we live in a throwaway, disposable society, and I think that's true. In my, I would say short lifetime, but in my lifetime, I think we've got away from repairing things to just throwing things away. It's crazy, utterly crazy. And there are plenty of examples of old buildings that have been around for at least centuries, maybe even millennia. An example here of a church from Norway. It's been standing for approximately 1,000 years. So it's a good example of efficient use of material. Those trees were felled, let's say 1,000 years ago. They've regrown, trees have regrown in that time, maybe 10 times over. So by having an extended use time, then that has the benefit of storing the carbon for a long time and also being very efficient with the use of the raw material. The other thing that we're certainly not very good at doing is thinking about what do we do after the use of wood. So when it comes to wood that has been torn down from buildings, removed from buildings, we are usually ending up with a pile of often broken bits of wood, which are then difficult to reuse. We don't really think about the reuse. We don't actually think about reuse much in products full stop. So most products are made without really any thought whatsoever to how we recover the materials. And some of these are very, very valuable materials. Certainly that's the case in wood. The picture on the right here, the bottom right picture is actually a picture that was done by a student group maybe 6 or 7 years ago. They decided they wanted to look at this idea of cascading. How could they actually produce something from waste wood? And they came up with this idea for a coffee table. I mean, it was rather nice. It worked very well and demonstrated that you can actually do something with just broken bits of wood. Will you excuse me a second? I must take a glass of water. Okay, so We used or produced in 2016, so the statistics from the EU and FAO, about 884 million cubic meters of sawwood and wood-based panels. To put that into some context, that's a cube of wood product, approximately a kilometre tall, and as your architects, you'd be interested to know you could put the Eiffel Tower 3 times on top of each other in that box. So it's a large amount of wood products that are being manufactured on a yearly basis. Of course, not all of these go into construction, but a large proportion do. So there's a lot of wood material actually going into buildings on a regular basis, and of course other products, but they're going into buildings on another basis. That is instead the equivalent to about 750 million tons of carbon dioxide. So that wood that was manufactured, removed from the forest, you could argue that removing it from the forest, you're creating an environmental problem, but in the sense that you are retaining the wood in solid form, in material form, and placing it into a building, you're storing the carbon there, and you're substituting other materials that would otherwise be used if you weren't using wood. So we could think of the built environment of buildings as a little bit like an analogous situation to the forest. It's a kind of a resource, it's a store of materials. So it's a kind of an urban forest, if you like. How much is actually available? Well, we've been involved in a few studies, and actually from a study that was conducted from a European project in which we were involved, which finished a couple of years ago. Approximately 32 million cubic meters of solid wood is present in residential buildings in Austria alone. We've actually I haven't put anything on the slides here because I've only just had the thesis, but I've had a student working with me now for the past 6 months, and she's been looking into the potential amount of wood here in Finland in residential buildings, and the value that she came up with was 17.1 million cubic meters. So there's a lot of wood actually embedded in the buildings, in the building stock at the present time. 17.1 million cubic meters is a very significant amount of material. So why don't we use it? Why don't we actually make use of this? And the prediction here for Austria, and I think when we look into it, we'll probably find the same will happen here in Finland, is there's an expectation that that amount of material will increase, and so there'll be an increasing amount of material available to be utilized in the future. So one of the concepts we've been working with, and I'm sure Satu will also be talking about this, is about resource cascading. So the idea here, the concept here, is actually to, rather than to lose the quality or the value of a material simply by disposing of it, then you retain the value or the quality by reusing it either in other identical applications or in other applications that have a high quality requirement. So rather than, for example, using a piece of sawn timber and then just chipping it up and putting it in the fire, you retain it in the solid wood form to make another maybe load-bearing element or another interior panel or whatever it might be. It retains the quality, a higher level of quality for a longer period of time. And you can repeat this in a cascade until eventually, by the time you've reprocessed it several times, then the quality has been lost and there's not much else you can do with it, but you have had a lot of utility, a lot of use out of that material throughout that time. So this is the concept of cascading, and I've got a pointer here, but here conventional use is what we do currently mostly is we have a material, we use it once or twice or whatever it is, and then throw it away. The idea with the cascading is that we extend the period of time so the quality is retained for longer. So if you think about carbon storage, we retain more carbon for a longer period of time, therefore we have a more efficient use of material.
So you might tell an example of product that would be extended, that service life would be extended.
You preempted my next slide.
Sorry, I'm already.
You're always doing that. I know. So this is an example of a wood cascade. So we might start out with, for example, solid wood. And then there could be subsequent solid wood products. It might be from a large beam. It has to be reprocessed slightly to make a smaller beam. And then once the beam has, thank you, has lived its useful life, it then has to be converted into particles, and that could be used to produce particle board. After that, when the particle board has maybe been in a piece of kitchen furniture or bathroom furniture, it's reprocessed again to create fibers. The fibers can be used in some fiber-based product, maybe some form of packaging, and then even the fibers could be recovered and then reprocessed, could be chemically processed into chemicals or into textile fibers, and eventually then reclaimed and used for energy production. So providing we don't lose material through the system, that material will always be available for energy production. It's just that we've made more use of it in intermediate products throughout that period of time. But this is the situation currently. This is what we tend to do, is we take solid wood and it up and chip it and then produce energy. And that's not a bad thing necessarily, because although we could make more use of it, we have to also consider what other inputs we would need to make to create these other cascaded products. And if the inputs exceed the benefits that we would actually gain from doing that, then it doesn't necessarily make sense. Maybe to give an example, maybe an extreme example, if we had lots of fibers, we wouldn't want to try to stick them all back together to make a solid piece of timber. That just wouldn't make any sense. You have too many inputs. So there comes a point where it becomes difficult. That's why I mentioned my little bit of skepticism about circular economy, because we can only recover a proportion. We can never really recover 100% of the materials. There will always be losses of some sort or another. But what we could strive to do is to create a step in here, for example, through the production of particle board. We don't do that here in Finland because we don't have a large particle board manufacturing base, but in many parts of Europe, Central and Western Europe, then there are particle board manufacturers who do already utilize quite significant quantities of recovered material, not from buildings, but from things like pallet wood, because of the cleanliness of the material. So many particle board products are already incorporating maybe 70–80% of recovered wood in their production. And that particle board is then available for the production of energy at the end of the day. What we would like to see really is actually another step where, first of all, the recovered wood would be utilized in a solid wood form before being converted into particle board and eventually burned. We may be able to put another couple of steps in there as well, but I think realistically, if we could go from solid wood to another solid wood application and then to particle board and then finally for energy recovery, we would still have an important positive contribution to make. So in short, what we're trying to achieve is, I think everybody's familiar with the terms of reuse, reprocess, recycle, recover, reduce, reuse, recycle. It's well known. So if we could reuse components from buildings, either in the existing form or in slightly modified form, that would be an ideal situation. If we can't do that, if we could do minimal reprocessing to enable the material to be reutilized in solid wood form, that would be great. If we can't do that, there'll be fractions that we can't recover in the solid wood form. We could then recycle that into particle board, or we could use it finally for energy recovery. So we're trying to ideally create more circularity into the system. So, what's the problem? Why don't we just do it? Well, this tends to be the issue. Go to a demolition or waste management company, we tend to see lots of bits of broken wood, and it is usually lots of bits of broken wood. Looking rather similar to this kind of picture. We have wood that's mixed with other materials, it's coated, it's in the form of systems, part of a wall system. There are often adhesives or insulation materials, certainly lots of metallic components to joints and things like that. These all make it rather difficult, and during the demolition process then the only relatively quick way to do it is to smash it with a grab, effectively, and that breaks up the wood. So a lot of the intrinsic quality of the wood is actually lost in the demolition process. And these are some examples of the type of... It's a piece of art. Yeah, actually, yeah, I was going to say, I thought it's the right form, isn't it? Piece of art. These are actually taken from our exhibition in Aalto. So, I mean, but this is quite typical. You see a lot of nails protruding. Actually, I recovered some of this personally, and last weekend spent quite a few hours removing the nails so I could reprocess it. Other things you see in addition to nails and those kind of things is you see plastics, polymers, insulation materials, sort of polyurethane foam here. This looks like Styrox. So all sorts of different things that are adhering, which make it difficult to clean it. And the other thing that's perhaps more problematic are the chemical coatings and preservative treatments that are often rather difficult to actually identify. So that's one of the problems with the practical recycling of wood. So I'm going to mention one of the projects. I'm going to mention a couple more projects. I'm very pleased that Petri's here because this is actually funded by Petri's program. The Circuit project. What we're trying to do is to really to understand, well, if we were to recirculate, if we were to recover wood in a form that made it more suitable for cascading, what would be the implications in terms of the sustainability? So what we're trying to do is we're looking at kind of hypothetical scenarios where, okay, what if we were a little bit more careful with our dismantling of the buildings? We use some kind of smart demolition practices to recover the wood in a better state. What effect would that actually have? Another thing would be, and I'm going to talk about this because I think this is an important point to make, is design for disassembly. What about if all the buildings that you build and design from here on in are built so that they can be fully dismantled? So you recover all the materials. That's a challenge to you as architects. If we could do that, what would be the impact? If we could recover the wood materials from those buildings and we could reutilize them in different products. We could either use them in new buildings, different buildings. If it's not into buildings, what about into furniture? What about into other such things? So what effect would this then have on the sustainability? So we're trying to model that, trying to understand what the impacts would be. It's challenging because it's difficult to assess what the current practices are because they vary quite a lot, and what would smart demolition practices actually look like. And as for design for disassembly, well, we've really got very little clue about what that would mean in reality. So the idea would be that we would see what would happen if we could shift the emphasis from this end of the spectrum more to the reuse and the reprocessing end of the spectrum by the introduction of a design for disassembly paradigm. I think I probably stated this already, but of course current demolition practices aren't really compatible with material recovery. They're compatible with quickly demolishing the building so that it can be moved on to the next phase, which is usually or often rebuilding another building on the same site. So we have another project that we are now working on. We're actually we're entering the third phase of this other project called ReWood. So I'm not very imaginative with names for projects. And actually this is ReWood 3 we're on now. This is ReWood 2, and we had a ReWood 1. So not very, very imaginative. I'm an engineer, so that's my excuse. But what would happen if we could actually design buildings that could be disassembled, or maybe not disassembled? We're not talking about disassemblable buildings. We're talking about buildings that can be that we can recover the materials and they can be reused. Not a modular building that is rebuilt somewhere else, but a building that is we can recover the materials and reutilize those materials. So we're now working on putting together a project where we will actually build a building, and I am working with architects on this. We will build a building that will then be dismantled, and the materials will be given as a starting point to a new set of architects who will then build another building from those materials. It won't be the same building, but something else. And we will learn that process. That's our aim, is that we will learn by it, because we don't know how to do it. And we need to learn by the experience. So this is something that we are now working on. We have a concept. We've just been had a workshop a couple of weeks ago, a workshop actually to do to scope out what this building will be and what it might look like. So I'm going to actually close now. I'm just going to mention the projects that we've got running, because they might be kind of make some kind of connections here. We have a project called the ReWood project. This is funded by Climate Kick. Some may be familiar with the EITs, the European Institute of Technology, KIC's Knowledge and Innovation Communities. We have a project where we're actually working in conjunction with, again, the Ministry of Environment, CITRA, UNFCCC, to look at digital technologies and the use of digital technologies to account for the carbon. If we could, the reasoning here is that if we can say with some precision what the carbon content of this building is, and if we make decisions about the building choices, design, what implications that would then have on the carbon content, then that would help us create incentive mechanisms that would help support the utilization of wood and roll out the use of wood construction. We have another project, again funded by Climate Kick, where we're working with partners in Sweden and Switzerland to look at developing a tool that would allow stakeholders, designers, architects, decision makers to make decisions about the materials that they use in buildings to enable them to select what the most sustainable choice would be. Often we believe it would be wood. It might not always be, but it would allow them to make a kind of an informed decision about the sustainability of the building. Circuit I've just mentioned. I won't talk about that. And we have another project in Futurewood, which is now, this is a European. We're looking at the resource base of materials in Europe, wooden resources in Europe, and how we can harness these to create new buildings. Looking at design for disassembly as a means to enhance the recoverability of the wood materials. And then the ReWood I've mentioned. Lots of acronyms, not very, very imaginative. All have got wood in them, haven't they? Yeah, okay. So anyway, so those are the projects that we're working on at the moment. I mean, if there's an invitation at a future point, I would be happy to come back and tell you more about these projects as they continue. So I think I'm more or less out of time. I managed to 27 slides or 25 slides last quite a long time already. Just some final thoughts, or maybe aspirations, if you like. I think it's certainly important as we go forward that we need to adopt systems thinking. We need to involve all stakeholders. And I'm an engineer, I'm a scientist. I'm used to being in a laboratory by myself or with a few colleagues, not really thinking too much outside that realm. But it becomes increasingly important that we involve all stakeholders in this process, because I think there is always the danger that, okay, wow, yeah, let's all make wooden buildings, and then suddenly we find, oh, we've run out of forest. That's not really a very good situation to be in. about this kind of materiality of products, then thinking about thinking of buildings as material stores. I know this is already changing, and there are very good examples of projects that are looking at materials as buildings as material banks. I think this is something that maybe we need to think more about. How can we just consider that, yes, okay, it's somewhere that we have as a space to live or work or whatever, but also how can we think about the materials that actually go into the construction to retain those and to give them value. I think materials need to be given value. Why do we tear down buildings so quickly? I mean, I was talking with a colleague of mine from the UK, and he told me that the average lifespan of a commercial building in London is 15 years. That's utterly crazy. I mean, I just don't understand it. I don't know enough about the building process and architecture to understand the phases that a building will go through during its lifetime. I think that's something that's really interesting to see. Maybe when we're talking about design for disassembly, we should be also thinking about design for adaptation, so that buildings can be more adapted to suit new purposes. And certainly we should be thinking too about designing buildings where we can recover the majority of the materials. And I have to admit that I think we think about a lot of products we use that go into buildings. They're actually quite complex. It makes it very challenging to actually recover the materials in the first place. So we maybe need to go back also to the points of the manufacture of the products, to think about how they could be produced in a way that would make the recovery of the materials much more, much easier. Very happy if anybody would like to make contact. Really happy to talk more about this. I'm always looking to engage, particularly with architects, to get their opinions on a lot of what you might think what I've said is a load of rubbish. I don't know, but. We certainly need to understand this in the kind of the idea of working with stakeholders. We need to work with stakeholders to try to understand what the issues are, what would help to promote the utilisation of wood, and also then this additional part of the circularity, the resource efficiency with wood construction. So, with that, thank you.